Hello, my name is Shai. I usually make animations like this one using procedural shaders, but I don't explain how to get these simple shapes like squares, circles, and triangles. So this video is all about those basic primitive shapes because they're very important for making really anything. So let's move on to the square. So the square can be made using a separate XYZ fed into absolute less than. Repeat the process for y, and then multiply them together to get this output. So here we have a horizontal bar, a vertical one, and we're multiplying these two together, and we can get a rectangle or a square. And if we move these two sliders simultaneously, we can do something like this. It's basically a scale, but instead of just uniformly scaling it, we can multiply this by 0.5 to get a rectangle. You can make all kinds of shapes like this, but that is the square. Let's move on to the circle. There are two main ways to make a circle. Number one is the separate and add method. We're taking x squared and adding that with y squared to get this output. And then from here, we can use a less than node to get a solid circle. But one issue I have with this is that we can do it easier with only one node. And also this gradient is non-linear, it's quadratic. So if I change this value at a constant rate, it's faster here and slower on the ends. Instead of using that method, I recommend we just use vector math set to length to get this linear gradient, then using a less than node to get this output. You can do all kinds of things with this, like for example, randomizing it. If you want to change the position of this circle, we can use another vector math node set to add. And this does work, but if you want all of this in one node, you can just use the distance setting. So here I'm going from length to distance, and this finds the distance between these two vectors. So I'm taking my object coordinates, finding how far they are from this vector. So this is basically just a circle that you can move all in one node. Pretty handy. So it's really a personal preference whether you use length or distance. It's all up to you. But now let's move on to the triangle. To make a triangle, we can separate x, flip the negatives, and add it with the y. This gives us a nice gradient. As usual, we can use a less than. This slides it up and down. And you can do tons of operations with this. For example, if I multiply and then use sine, I can get a wave pattern. It's kind of like an up arrow. And at any point, I can multiply the absolute of x to change this horizontal scale, if that helps you visualize it. Triangles are pretty cool. I really like this method of making one. On the topic of triangles, if we have one triangle, we duplicate it to get two of the same. We can rotate this second one by 180 degrees. And if we take these two triangles and multiply them together, we can get this result. So once we have our duplicate, we can take this triangle, multiply it by this triangle, and get a hexagon. Instead of using this method to make a square, you also have the option of using a compare node to simplify this. So instead of using absolute and then less than, I could simplify this to only use a single compare node with a value of 0 and an epsilon of 0.5. This works too. So there's tons of ways you can make any of these shapes. There's no real right answer. It all comes down to how you want to make it. And you might even find out a new way to make a shape that you haven't been taught before. If we duplicate this setup, rotate this by 45 degrees, and then multiply these two together, we can get an octagon. And here's a polygon with 16 sides. That is called a hexadecagon. Pretty cool. I hope you liked the video. I hope you learned something that will help your procedural journey. Man, I really hope this video blows up. Like and subscribe. Wait, no, that's not what I meant. No, please, just...